All right, let's polish off problems 20. The last two problems, 29 and 30, in this set of solutions to the practice final exam. We can do so lickety split here. Problem 29, for instance, falls into the category of a problem that you can do much more quickly than you can explain how to do. So let me show you what I mean. Here's 29. Let me read it. It says a randomized experiment was performed to determine whether two fertilizers A and B gave different yields of tomatoes. A total of 33 tomato plants were grown, 16 using A, 17 using B. The distributions of the data did not show marked skewness, and there were no outliers in either data set. The results of the data are shown below. Now, I got to tell you, when I first read that, I didn't see any reference to standard deviation, so I mistook that for a hypothesis test for two means with the standard deviations unknown. But if you look down at the table, not only are the average yields or mean yields given, but so are the standard deviations and so is the number of plants. So this is a hypothesis test for two means with known standard deviations. So what do? We just set up, like we always do, the null hypothesis, and that is that these two means A and B are the same. A equals B. Mu of A equals mu of B. And the alternative hypothesis, I have to go back up, and it says in the first sentence, a randomized experiment was performed to determine whether or not they gave different results. So that means mu of A minus mu of B is not equal to 0. It's not that A is bigger than B or B is bigger than A. They're just not the same. That's what we're testing, all right? And so in this case, what you can do is go directly to your calculator. Yeah, and where you're going to go with your calculator is stat, tests, and then we're going to go to two. Let's see what it is. I'm blanking a little bit on what it is. It's two sample z-tests. Two sample. I'm taking samples from two different populations. It's a z-test because the sigmas are known. And when I go to that, let me show you what the input is expressly, since I figure out how to do it. I'm going to go stat, tests, down to two sample z-test. And here's what it wants to know. It wants to know what's the input. And the answer is stats. It wants to know what the two sigmas are, 1 and 2, and we're going to let 1 correspond to A and 2 correspond to B. So I'm going to put sigma 1 in, which is 3.68. I'm going to put sigma 2 in, which is 4.93. And then it wants to know what x bar 1 is. X bar 1 is 19.54. And what N1 is, and N1 is 16. Then it also wants to know, of course, corresponding numbers for the second mean, B, 23.39, and is that 17? That's 17. And the last thing we have to do is to tell it what type of test is this. 2-tail, 1-tail, no tails, 3 tails. You have to cover mu 1 does not equal mu 2. And when you do that, and you tell the calculator to calculate, you get, the only thing we really need to look at here is P is equal to 0.0107. And now, what's left for you to do is to go down to the answers. And if you go down to answer D, it says there is evidence of statistically significant difference in the yields between fertilizer A and fertilizer B. And then parenthetically they say because P is between 0.1 and 0.5. If you check the others, A, B, C, and E, P falls outside the range one way or the other that is given. So that's problem 29. What we're going to do is fade away, erase the board, come right back, and we'll do the last problem 30. All right, see you in a second. All right, and finally problem 30, the last problem here, and fittingly, it's a problem on a topic that is right in the heart of everything we've been doing in inferential statistics at any rate, because it's a problem associated with the central limit theorem. Let me read it and solve it shortly thereafter. There are 5,317 previously owned homes sold in a western city in the year 2000. The distribution of the sales prices of these homes was strongly right skewed, with a mean of 2,006,274 and a standard deviation of 37,881. So let me get that down. We get a population that is skewed. Say anything else about it? Skewed. It's got a mean of 2,006,274, and it's got a standard deviation of 37881. All right, what you do then, and then listen to this next sentence. It says, if all possible simple random samples of the size 100 are drawn from this population, and the mean is computed for each of these samples, 100 means, which are the following, sorry, not 100 means, if all possible means, thousands of means, right? Tens of thousands of means, are computed for each of these samples, which of the following describes the sampling distribution of the sample mean. So, the central limit theorem says, independent of whether it's skewed or not skewed, okay, if you take samples of the appropriate size, less than 10%, okay, and here we have samples of size 100, and you take all such simple random samples available. There's an awful lot of size 100 simple random samples in a population that is got a size of 5,317, an awful lot of size 100 samples in that. If you take each one of those samples and take the mean and find the distribution of those sample means, the central limit theorem says that that distribution will have a mean of that's equivalent to the population mean. I'm struggling to remember what the notation is for that sample. I'm sorry. I'm going to just call it hat for the second, just to distinguish it from that. And it will have a distribution, a standard deviation, which is equal to this standard deviation, but it's divided by the size of the samples. All right, that's 10 divided into that means that that is 3,788.1. All right, so if we just start looking down the list, A says if I'm going to describe the sampling distribution of the sample means, it's approximately normal. It has a mean of this. It has a standard deviation of that. You can read the others, B, C, D, and E, but A is the answer. All right, I hope you worked through all of these and learned something. Didn't learn too much because you should have known all this coming into this test, but maybe you picked up a few things, or maybe you reinforced some things that you were a little bit weak on. All right, thanks very much.